Question: divide an array into subarrays with minimum cost 2. So you are given a 0 index array of integer nums of length n and 2 positive integers k and the distance. Now the cost of an array is the value of its first element. Okay, suppose this is the subarray, then the value where its cost is the first element of that subarray. So for example, 1 to 3 is 1, and while the cost of 3 for 1 is the first is 3, so 3. Now we need to divide the nums into k disjoint contiguous subarray. Disjoint means there should not be any common between those subarrays, such that the difference between the starting index of the second subarray, means this one, starting area of the second subarray, and starting index of the kth subarray should be less than or equal to the distance. Okay, so always means suppose we have given a range like from 1 to distance, you have to divide k minus 1 subarrays or select k minus 1 starting indexes. So, and the starting index of the kth subarray should be less than or equal to the distance. So we have to return the minimum possible sum of the cost of these subarrays. So either we can see this first one is always the answer one. After that, either we can select the k minus 1 subarrays, then sort it to get the minimum k minus 1 value. So that will give TLE, as it is hard mark and the constraints is also up to 10 power 5. So we will simply be using here heap to always keep track of the smallest value. So first let's import heap queue. We will be also needing dictionary, so import that from collections, import default dict. Now first take the len of nums, n is equal to len of nums, and this first element is always in the answer, so we can simply store it in the base variable. Base is equal to num sub 0. Now we will be using two heaps. So first will be the small, which will keep track of k minus 1 small elements, and it will be a max heap, so that if there is any large value and we have to remove that, we can remove that in big of one time complexity, as it will be in the top. So we'll be keeping it as max heap. Second will be the large heap, which will keep track of other elements other than the smallest k minus 1 element, and it will be stored at the mean heap value, so that we can remove the minimum value from the large in big of one time complexity. Okay, so now we can simply create a delayed dictionary to keep track, to mark the elements which needs to be deleted. So delete is equal to default dict of integer. That's why we are imported here default dict. So delete is equal to default dict of integer. Now we can simply keep track of some things like sum of this small array, small heap, is equal to 0. Then small size also matters here, because we want k minus 1 elements only. So let's first mark it as 0. Now we will be using sliding window technique. So first we will mark our left pointer here from the 1, because first is always in the answer, so we will start from here. So left is equal to 1, and other thing, we can simply put answer is equal to float infinity as the initially we can put answer as infinity. Now simply run the, now what we can do, we can simply run our sliding window for right in range n, on right in range 1 to n, on right in range 1 to n. Yeah, so first thing we can do is always first add nums of right, add function we will create later. Okay, now suppose if while right minus left, suppose this distance become more than the distance, so we will have to remove some elements. While right, as the difference should be only up to the distance or less than that, so we will if the distance get greater than that, we have to remove some elements. So we will remove the left one, so we can simply remove nums of left. We will create this left afterwards and increment the left pointer. Left plus is equal to 1. And now suppose this size, this is small size which we have defined here, it becomes equal to the k minus 1, means we have got a k minus 1 smallest integers. So if small size is equal to k minus 1. We can simply compare it with the answer. So answer will be, answer is equal to minimum of answer, and what will be the other sum? Sum will be, first this sum is small and this base sum, which is fixed in every array. So base plus sum of small, and finally we can simply return answer. Now we have to create few functions, so let's do that. So first we will start with the add function. So as we have defined, to add nums of right, so let's first define this. So define add function, which will take an input as x. Now we will be using this sum small, we will be modifying this sum small and small size. So first let's our function know this. So non-local sum small and small size, non-local sum small and small size. Now our functions know which things to modify. Now suppose if there is a small and this x value is less than or equal to minus of a small of 0. Minus means because we are putting this, we have defined a small as the max if. We can write here as comment, we are using this as the max if. So in max if we store it with the negative sign, so that it will be, in Python it is always implemented in the main if. So to store it as a max if, we can simply reverse the signs. Okay, so if suppose if x is smaller than minus, means minus small of 0 means it should be in the top smallest k minus 1 element. So we should simply add it here. So heap q dot heap push, what to push is small, and with the, as this is a max, add it with the negative sign. Then this sum of small which we have defined here will increase, and sum of small will become sum get added with x, and its size will also increase. So small size plus is equal to 1. And so suppose if this is not the case, then simply we can add it in the with the all other elements in the last. So simply heap q dot heap push, and as it is the main heap, there is no need of negative sign, we can simply with x. Okay, and we will create one more function called rebalance, which we will call at the last. What it will do, it will always keep track of that there are only k minus 1 or less than elements in the small, and rest others are, suppose we added more than k minus elements in the small, so rebalance will remove those elements and put them in the large. And if there are few less elements there and large is also there, so then it will add few elements from the large to the small. So this will be the function of the rebalance. We will create it later. Let's first create this. What we have used another thing, remove function, and we can simply add remove, we can simply add remove here. So again we will have to modify this sum small and small size, so we will call that. So non-local sum small, what else, small size. Yeah, so suppose now we have defined delayed here, right? This delayed is equal to integer. So if we have to remove any or mark, here we are just marking an elements to be removed logically, we are not removing it currently. So we will just mark it as delete of x plus is equal to 1. Okay, so that time we have to delete it. We are just currently logically marking this. Suppose, and now if small is there and x was less than equal to minus of a small of 0, that means the element which we are removing was part of the k minus 1 smallest elements. Then we have to decrease its sum from the, small sum, and we have to also decrease the size. So small size minus is equal to 1, and at last we have to again call the same rebalance function. Okay, rebalance function to rebalance everything. Okay, so now here in this remove function we have just marked them to be deleted. We have not actually deleted those elements from our heap. So what we will do now, we will simply create a clean function to clean the elements which are marked here to be deleted. So simply create a clean function. So define clean and it will take input as heap. Okay, so it will simply see, we can't directly delete here because suppose we have asked to delete this element as, and it is not the top element of the heap, so it will not be deleted in big O of one time complexity. So that's why we are just marking this, and when this element comes at the top of the heap, we can simply remove it in big O of one time complexity. So for that we are creating this separate heap function. So while heap, and suppose x is equal to heap of 0, the top element which we have fetched of the heap. Okay, so value will be, as you know, minus x if heap was small, heap is small, as a small heap is a max heap. Okay, else it will be simply x if it was large on the main heap. Now same thing, if delayed of value is greater than 0, as we have said here, if plus 1, if it is marked to be deleted, it is greater than 0. Okay, if delayed of value of x is greater than 0, we can simply say delete of val, simply mark it as minus is equal to 1. We can decrease its value and simply heap q dot heap, we will pop this value, heap q dot heap pop from the heap, whatever it is, small or the large one. And if it is not the top one, so we can simply break out of the loop. Nothing else we can do here until it comes at the top. So what all things we have done, we have created the remove function, then just mark which all elements to be deleted, then we have created the clean function, and finally remove those. And finally remove the, we also created the add function here, which will keep on adding elements, and now what is left is just the rebalance part, this rebalancing, which is the most important part. So first we will create this rebalance. Okay, it does not take any input any. Okay, so we can simply first clean both. If anything is marked to be deleted, just go to check and delete that. So clean small and clean large. Okay, and now what we will do, now we have to maintain k-1 elements in the small array and rest elements in the large. So first we will check, suppose if small size, suppose small size has got greater than k-1, it has got more elements than k-1, so we will have to simply first clean this small. Okay, now we will simply pop the value, the larger values we will pop out of here. So x is equal to heap q, x is equal to minus of heap q, because it contains negative value, and we will get actual value of x by putting this negative sign. So minus heap q dot heap pop from the small, and of course the sum of the small elements will decrease by x, and small size will also decrease by small size, minus is equal to 1. Okay, and the elements which remove, we can simply add that to the large one. So heap q dot heap push, we have to push in large, what to push x. In the similar fashion, while small sizes, suppose less than k-1, and there exists elements in the large heap. So what we can do, first simply clean, so that no values marked as deleted to be at the top. So simply clean large. Okay, now go x is equal to heap q dot heap pop from the large. Okay, and we will add from the large, we are popping the top element. So top element is always the smallest in the large, and in the small the top element is always the largest. So now we can simply add it to the small array, sum of a small plus is equal to x, and the size will also increase. So small size plus is equal to 1, and we can simply add it. So heap q dot heap push, we can push in small with the negative sign as it is a maxit. So I think our code has been completed, and yeah, so let's try to run this now. Oh, so we are getting some error heap post. Okay, we have messed up p here. It's actually heap post double p. Cannot access local variable small size where it is associated with the value. Okay, let's check where we are getting this error. While small size, again, let's see, we are modifying this small now. We are modifying this some small and small size, but we are not letting our function knows what to modify. So we have to define that non-local sum small comma small size. Let's try to run now. Again issue. Okay, has no attribute heap pop. All the spelling mistakes. It's double p heap and then pop, the method name. Okay, hope it works this time. No, infinity is also valid for the expected return type long. Didn't get what the type. Infinity is not a valid value for the return type. Okay, where we have written it. Return answer. Okay, answer is equal to minimum of answer comma plus sum of small. Answer is equal to minimum of answer from sum of small. This debugging part is really hard. So answer, where we have defined answer is equal to float infinity. Okay, answer is equal to float infinity. Answer is equal to float infinity. Then define clean wale people 0. Getting a runtime error. Some small size. It is not telling the return answer. It's outside of row and return answer base plus sum of small. Sum of small. The error what is telling infinity is not valid value for the expected return type long. This type error plus is not terminal float cannot be serialized. Where have we got this issue? Let's check again. N is equal to len of nums, base is equal to nums of 0. Small and large we have defined. Delete default integer. Okay, no issues. Heap q from collection import heap q. In clean heap, while heap x is equal to heap value is equal to if x is small else x. If delayed value is greater than 0, delayed value minus correct. Heap q dot heap pop heap. Heap q dot pop heap. Yeah, correct. Then rebalance function non-local sum small size. Clean small, clean large, no issues. While small size is greater than k minus b, we can simply clean small and x is equal to, we can get the value minus of sum small minus x small size minus 1 heap q. Okay, this is also correct. Then while small size is less than k minus 1 and large is there, clean large heap q dot heap pop from the large and add that value to the small, increment the size and again push that value into the small with a negative sign. So now what is the add function? Sum small size is small and x is less than equal to minus small of 0. Correct. The heap q dot heap push is small with the negative sign and sum of small will increase and sum small size plus is equal to 1. Okay, now else heap q dot heap push large. This is correct. Then remove sum of small size, delete of x plus is equal to 1. If small and x is less than minus of small of 0. Okay, then rebalance. Okay, for right intent 1 to 9, add of nums of right. While right one level greater than distance, we can remove the element and increment the left value. Then if small size is equal to k minus 1, correct, then answer is equal to minimum of answer minus sum of small and return answer. Let's try to run. So many this typo mistakes now. heapq dot hip pop. Again hip post. When you write whole code at once, now you got so much errors. Yeah, so our test cases have passes. So that runtime error which we were getting was because of this. We have missed this plus sign here. Now we try to submit this. Yeah, so our code has passed successfully. Thank you for watching.